Greetings viewers, welcome back to the channel. In today's video we're going to talk about Subaru head bolts. Are they stretch bolts? Are they torque to yield? Are they reusable? A lot of information going around the internet regarding this subject. A lot of it false, a lot of it hearsay. Let's try to go through the process and figure out what's fact and what's fiction when talking about Subaru head bolts. So when talking about head bolts on Subarus, you get into the subject of the head gasket failures. We covered that in the last video, or the last talking points video on Subarus, and tried to dispel a lot of myths about Subaru head gaskets and all Subarus having head gasket issues. But aside from that, we're here to talk about the head bolts. So when replacing head gaskets, do I have to replace my head bolts? Short answer is no. Thank you so much for watching. Glad you joined in. Joking, we're not going to let it die that easily, but yes, you can reuse your head bolts with no issues. I know a lot of you are probably saying, well, wait a minute, these are torque to yield bolts, these are stretch bolts, there's an angle involved. You're supposed to throw these away and replace them with new bolts, right? Well, not the case when it comes to the head bolts on Subarus. There are differences between a standard bolt and a torque to yield or stretch bolt. If you look at the little visual I have here, normally it's a visual thing. You can easily spot a torque to yield bolt as compared to a standard bolt. Normally on a torque to yield bolt, they have a chamfer, a little smaller area. This is where the yield, the stretching of that fastener actually takes place. Standard bolts normally are uniformed, their thickness from the head to the threads all the way through. So as we see with a Subaru head bolt, I have both a single overhead cam head bolt here and a dual overhead cam head bolt here, which is a slight bit shorter on the turbo head bolt. I'll have a little visualization a little bit better than you can see these. But that said, what other indications do we have that these are not actually a stretch bolt? Back to the service manual and the fact that you put an angle on these bolts when you tighten them. Well, putting an angle on a bolt or degreeing a bolt is not always a sign that you're deforming the bolt or you're stretching the bolt. There is a difference between a TTY, torque to yield fastener, and a torque plus angle fastener. The reason that some manufacturers give you an angle reading is due to the nature of torquing a fastener. When you torque a fastener, what you're doing is measuring the force exerted on that fastener to the two pieces that it is clamping, binding together. You want as accurate a reading as possible when doing this, but you cannot, unless you are in a perfect world, get the true exact measure of torque on a fastener. One of the main hindrances is friction. You have to calculate for friction at the head of the bolt. Washer, if there is a washer, you have to worry about the friction in the threads. You have to worry about the friction in the channel that the bolt goes into before it gets to the threaded section. You have to worry about the material that the bolt is made of, the material that the objects to be clamped together are made of. And you also have to be mindful of anything between the two pieces that you're clamping together. In this case, the cylinder head and the block, we have the head gasket in between, so we have to account for that squish of that head gasket. So a way to be more accurate in torquing something is to do an angle or degree to that fastener. When you're torquing with a traditional torque wrench, as I said, you have to worry about friction playing a role in getting your torque figure inaccurate to X percentile. We don't know exactly what. It all depends on what individual fastener you're torquing at that moment and how everything is put together. So instead of torquing to a Newton meter or foot-pound measure, a lot of manufacturers give you an angle. It doesn't matter the friction, the calibration of your torque wrench, any of that stuff is all out the window when you have an angle. because it doesn't matter as long as you're turning that fastener that angle. If it's 90 degrees, 30 degrees, 60 degrees, it will always be the same 90 degrees, 30 degrees, 60 degrees, whatever, no matter what other outside forces are acting upon that fastener. So that is what Subaru elected to use when doing the head gasket procedures on Subaru cylinder heads. So to the actual torque process, we're going to cut to a clip right now. I'm doing a mock cylinder head installation on a junk block of a junk cylinder head and junk head gasket. I'm going to go through the factory torque procedure and show you exactly how tight the bolts get in stage 1 and stage 2. Now, when talking to most people, they believe that the first stage of torquing and tightening before you loosen the bolts is a stretch procedure to stretch your head bolts. That is not the case. What you're doing in that first procedure is compressing the head gasket. You're taking all the squish out of the head gasket. You're also helping to align the cylinder head on the block, get everything where it needs to be in preparation of your final torquing. That is why at the beginning, I'm going to put the procedure here on screen. You put the head on, put your bolts in. You want to lubricate your bolts very well to help alleviate any friction, because these bolts are very long and they have a lot of threads just due to the design of the engine, and that gives a lot of leeway for inaccuracy when torquing these fasteners. So you want to make sure that the head of the bolt, the washer, all of that has a good coating of oil on it, as well as the threads. You want to make sure there's no debris or junk down in the bore where the bolts are going. You don't want any kind of crud in there that can mess with your torquing. So you put your head on, you run your bolts down to snug, just till they touch, just draw down. You go through and you torque. I believe the first step is 29 Newton meters. Again, I'm going off my top of my head. I'm going to have it here on screen. If I'm wrong, sorry. Like I said, going out of memory. Torque them all to 29 Newton meters, and then I believe you torque them all to 69 Newton meters. Then you loosen all the fasteners 180 degrees. You loosen them another 180 degrees. Once you've done that second stage of 180 degree loosening, the bolt essentially is completely loose. It's just barely making contact with the cylinder head. It's not applying any force whatsoever. Again, that is just to squish down that head gasket, take that play out of there, and get that as much out of the equation as possible before doing the final torque. And we'll demonstrate that in this clip that's coming up. We torque them to a maximum, like I said, of 69 Newton meters. And once we go through the second step, the second stage of torquing the head, you'll see in the video that it's much tighter. The bolts are much tighter than that first step. So we didn't stretch the bolts in the first step. What we did was compress the head gasket, align the head on the block. That's what that step's for. So the second stage, we go through and we torque them all to, I think it's 15 Newton meters. This is my procedure, not the book. The book says to torque the two inner head bolts, and then you torque the outer head bolts to a lesser value. What I like to do is torque all 6 in order to that lesser value, 2 revolutions. That way you make sure they're all where they need to be. Then go back and torque the 2 center bolts to that higher spec. Then you torque them all, well, turn them all 90 degrees, then you turn them all in order again another 90 degrees. Once you've done that, the outer head bolts are torqued to about 80 to 82 Newton meters, and the center bolts are torqued in the mid 90 Newton meter range. So far past that 69 Newton meters of that first step, then before we loosen. So again, that's not stretching the bolts. If the bolts were to stretch at any point, it would be after you have torqued the final torquing of the cylinder heads, because they're at a greater amount of force being applied to the fastener in the cylinder head and block. So I'm going to cut that clip real quick. You'll see that in action. When we get back from that clip, I'm going to have those head bolts that I've already installed torqued again. They've been through at least 2 torque cycles, probably 3 at this point. I believe the vehicle had about 200,000 miles on it, so it's probably had at least 1 head gasket replacement already, although the head gaskets in that car were the prone to failure single layer graphite coated head gasket. So I'm hoping those would be the factory installed gaskets and not ones that have been replaced with the bad part a second time. So that clip now. All right, so we'll go ahead and install the old head gasket. This side had not blown on this engine. It was the driver's side. Now, before you install the cylinder head, you want to put your head bolts in the head or else you're not going to be able to get them in. Make sure you thoroughly lubricate the threads, the washers, and underside the head here. Don't just have them sopping, dripping with oil when you throw them in the bore. You don't want to have a lot of excess oil in there that could cause binding when torquing. You don't want the space between the bottom of the bolt and the bottom of the bore full of oil. When you go to torque it, you could risk cracking the engine block. Similar to sucking water into an engine, hydrolocking it, when the piston comes up, it can't compress the water and it's usually going to bend the rod, or could throw the rod through the side of the block. So every Subaru has a little bit different head bolt length and a little bit different markings on the bolts. This particular 2000 model Outback with an EJ 251 single overhead cam, we've got 4 head bolts here that have a dimple in the middle and 2 smooth ones. The 2 smooth ones go in the center position. The 4 dimpled go in the 4 corners. So just make sure you got your head bolts in the right location in the cylinder head as well. One reason why I always pull the engine to do cylinder heads on Subarus, it's not worth the frustration to do them in the car. So now that we got that in there, we're just going to run all these head bolts in till they contact the head. All right, so we've got our bolt just to run down to the top of the cylinder head. We haven't got any torque exerted yet. So step 1 of the process, we'll be torquing in a specific pattern. We will be torquing our bolts the first round to 29 Newton meters or 22 foot-pounds in the alphabetical sequence, which I will display on the screen. So second, we're going to torque them all to 69 Newton meters or 51 foot-pounds. You hear that creaking and squeaking? That's not something you want to hear. When you hear that, it means you do not have enough oil in either the threads in the block or the threads on the bolt. That means you've got too much friction and you're not getting a proper amount of torque on that bolt. So when we go through the loosening process in a minute, you can take that bolt out, lube it back up, and get it ready for the final torque. See, that's what we don't want. We don't want it jerking. We don't want it jumping, creaking like that. You don't get an accurate torque reading when your bolt's doing that. Nice like this, quiet. Going through to get your torque number. All right, so all our bolts were quiet except the center bottom one. That's our issue child, problem child right now. So we're gonna need to lube that one up. So now that everything's been torqued to 69 Newton meters or 51 foot-pounds, you're going to back all the bolts off 180 degrees and then 180 degrees again. I'm going to do this in sequence as well. Well, you can do it in sequence. It's not really required. It doesn't specify in the service manual, but good rule of thumb. Actually, not the torquing sequence we followed, tightening. We'll go in reverse. So we'll start here, 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 bottom, and then the middle. So all we're going to do is a double 90-degree turn. If you know, a 90-degree turn is a quarter turn of your ratchet. So we're kind of just going to judge here and do a half of a turn across a horizontal plane. So starting here and ending there. That's 180 degrees. As accurately as we can eyeball it, that is. Again, it gets really hard to do this in the car, especially when you get to do your angles and your degrees. So again, I do advise people to remove their engine. Doing head gaskets is far, far easier to do. So what we're going to do on this one is two 90s. Well, we might be able to get 180 in one swing. Should have got a longer handled ratchet. Yeah, it's about 180 there. So here we got stuff in the way, so we're going to go about 90 here. Come back. Go 90 again to make 180. Again, that squeaking and creaking, not something we want to have. And 180. So now we'll go back again and loosen them all by 180 degrees once more. So as I stated, this process does not, I repeat, does not stretch your head bolts. That's not what this is for. What this process is for is squishing your head gasket, so to say, squishing it, seating it. It is also to help get the head aligned on the dowels, get everything ready to go and ready for your final torquing. All right, everything's been loosened to 180 2 times. And just to show you, this is finger tight. The bolt head is just barely contacting the surface of the cylinder head, just barely holding it on, not letting it to drop off away from the block. From here, we actually start torquing the head. We've already collapsed our head gasket, seated the head on the block, and we're ready to go for the actual torquing of the cylinder head now. So now what we're going to do is tighten bolts A and B in the center to 34 Newton meters or 25 foot-pounds. All right, 35 Newton meters, let's go. .1. Hopefully this one does not creak, but I'm sure it will. And it is. Let's see, we don't know if that's an accurate torque or not because it stopped at a creak. So that's why you do not want to put these things in dry. You want them well lubed. You do not want them having any kind of friction binding them up during the final torquing. All right, so now we torque our outside bolts to 15 Newton meters or 11 foot-pounds. When I do this, I like to do it a little bit differently. I like to torque everything in sequence, 2 or 3 goes to the 15 Newton meters, then come back and torque the centers to the 34. That's just the way I like to do it. I'm not saying it's right or better than the factory service manual's way of doing it, but I feel it brings everything down a little bit more evenly and accurately doing it that way. check real quick. All right, now that that's done, we're to the home stretch on this installation. Now what we got to do is tighten all the bolts in order 90 degrees. Then we'll go again another round 90 degrees, and that'll be our final torque. So this gets really tight, so what I'm going to do is I'm going to get out my 1/2 inch Snap-on Tech angle. It has a built-in angle meter, and when you torque to that specified angle, it will also give you the reading in foot-pounds or Newton meters to how tight the fastener was after that angle is applied. So we're going to do that and look and see exactly how tight these things actually are in foot-pounds or Newton meters. If you do not have a fancy torque wrench with an angle meter, you can do it with a breaker bar. It's way easier to do outside the car. You just turn a quarter turn essentially. So if you start your ratchet here at the 12 o'clock position, you want to stop over at 3 o'clock position to be 90 degrees. So let's go ahead and do our 90s and see where we're at. Great thing about this, it's got a little gyroscope built into it, so you don't have to do your 90 in one full swipe. It does track your angle as you tighten. Great for doing it in car, because if you come into contact with something, you can back up and continue to turn till you get your full 90 in there. All right, so after that first round of 90s, we're at 48.3 Newton meters. So let's go ahead and do our final 90 and see how tight these things actually get. All right, so after our second 90, we're at 98 Newton meters. I have to do the conversion to foot-pounds after I get done torquing all this. Our outside bolts are at about 84 Newton meters. Remember, we started with them a little looser than the centers. So about 98 Newton meters on the centers and about 84 on the outers. All right, so we got our 90, and you can see 81.3 Newton meters. More than the 69 Newton meters we went the first time. So right there, you can see the second torquing, our final torquing, is tighter than that first torquing before we back them off. So that first procedure, torquing and backing them off, is not there to stretch the bolt. All that is to collapse that gasket, make sure you're mounted up really flushly to the block with the cylinder head, taking out as many variables as possible before you do your final torque. So that's why they go to a torque plus angle. It's not because it's a torque to yield, but it's because it's a more accurate way to torque it when there are really long head bolts like the Subarus use. There's lots of area for friction and other things to throw the reading off, so they do not rely solely on a torque number. They give you that degree so they know it's where they want it or within a range that's acceptable. So with that said, I'm going to remove this head again. We're going to take these bolts and we're going to compare them to a brand new bolt that's never been installed to see if there's any stretch in it, to see if it has deformed past the point of elasticity into plastic form, which is where the bolt deforms to a point where it no longer can hold its original size or shape. It's where it's been torqued past its yield point, which would be a torque to yield fastener, and does not come back to its elastic original shape for once the torque is removed from the fastener. All right, guys, so as you saw in the clip, we went through the procedure. The second stage of tightening the head had the bolts much tighter than that first stage. So now I've got two brand new head bolts. I've got the old head bolts out of that single overhead cam engine, and I also have some used head bolts out of a turbo engine, dual overhead cam. And we'll compare the two for any stretch or differences in those bolts. Like I said, they've probably been torqued at least twice already. So take that in mind. So here's our dual overhead cam bolt, still in the bag. This Subaru part number 11095AA042. Blue head. There was a TSB on the changing of these head bolts. I believe in the 2000s they changed the actual, I don't know if they changed the actual bolt. I think they changed the coloration and this orientation, what position it was in the cylinder head, because there is a specific order or place they need to go. Then we've got the single overhead cam bolt, black head. I believe the part number on this is 11095AA. 123. No, the 123 is the other bolt. This one is I think 242. I think it's the last three digits of the part number. I'll put it on screen. I'm going off memory again. So here's our brand new head bolts, never installed. Here is our used head bolts. So first we're going to compare the turbo dual overhead cam head bolts. Unscientific test here. We don't have any calipers or measuring tools, but end to end, washer to washer, tip to tip, not really any difference to measure with the eye. And single overhead cam bolts again, end to end, both touching. They don't have any measurable amount of stretch in these bolts. So on screen now is showing actual true stretch bolts, new versus the old. This will be a engine that is really available, really popular, and there are literally millions of them out, and they are notoriously known for having stretch bolts in both their heads, the mains, and the rods, and that would be the GM LS Architecture V8. So looking at the GM head bolt, you can see that with the naked eye, there is quite a bit of difference between the old bolt and the new bolt. It's a lot longer, well, I'd say a lot relatively speaking, but you can see that it's been stretched past the point of elasticity, and it's now entered the plastic stage where it has deformed and will not spring back to its original state. Looking in the service manual, there is a warning, a section there specifically telling you, discard the bolts, they're one use only, install new fasteners. If you look in the Subaru service manual, there's no mention of discarding the bolts, there's no mention of installing only new bolts, nothing is mentioned in the factory service manual, nor is it mentioned in any of Subaru's training. I wouldn't know personally, but from other technicians, they do not advise replacement unless, like I said, there is some kind of damage to the fastener is broken, it's corroded or damaged in some way. When talking about fasteners, real quick, we'll talk about that. When you're looking at the strength of the fastener, as you tighten it, it goes through basically three stages. The first stage is where it's in its elasticity range. That's where it can exert a clamping load force on an object. Once it is released, once the torque is taken out of it and it's loosened, it will pull back to its original shape. That's why it's called elasticity, like a rubber band stretched and released, comes back to its original shape. That's the regular bolt. That's like what the Subaru head bolts are. You go past to the very upper end of the elasticity, you start getting into the yield stage. Yield is when it starts to stretch the fastener past the point of elasticity and you reach the plastic stage. So once you get past the yield stage into that plastic stage, then you get into the ultimate shear area, which is the amount of force the fastener can take, deforming and deforming and deforming until it finally fractures and breaks and lets go. So that's a little bit about the fasteners and torque exerted on them. So the Subaru head bolts, as we see, they're not deforming where you can tell with the naked eye they've deformed. They are not stretching, they're not damaged, they are a solid shank all the way through. So there is no issue reusing these head bolts. If you go to the Subaru dealership, Subaru techs all reuse head bolts. Subaru has always reused the head bolts. Rarely do they ever replace them. Now there are some times when you would replace them if the bolt, one, was broken, if it was damaged in any way, if there was a lot of corrosion or something happened to the bolt, like corrosion or whatever, that would affect the strength of that fastener. That is when you'd replace them. But a typical cylinder head gasket replacement, you do not need to replace them. It's a waste of money. If you do elect to replace them, that's fine. That's your money. You can spend it if you want. If it gives you peace of mind to put new bolts in it, go right ahead. That said, I can only recommend you use factory Subaru original bolts. So another area where you may want to discard your head bolts is if you have a turbo application, WRX, STI, Outback XT, Forester XT, etc., and you are running a high performance engine build, you are larger turbo, larger amounts of boost, etc., you will have issues with the stock head bolts where they will get past their clamp load and you can actually deform the bolts in that situation and lift the cylinder head slightly due to the boost pressure, and not a good thing to happen. So popular upgrade is to stud the engine. You take the bolts, chunk them out, and you basically will replace those bolts with a threaded stud. So when you switch to a head stud compared to a head bolt, you are gaining more control over the force of that fastener to hold the cylinder head down. You're getting more accurate torque readings, and that fastener can do a better job than the head bolt can. There's a couple reasons why. Well, first off, with the head stud, there's no actual bolt head on it like with a bolt. You just have a threaded stud. It's a piece of metal with threads on each side. You thread them down into the cylinder block like you would installing the head bolts, but you just snug them down. You don't have to torque them into the block. You slide your head gasket over those studs, your head down. ARP gives a special lubricant they want on the threads for the final torquing. You use a washer and a nut, and you torque that nut and washer down on the stud. Well, here's how it's got the advantage, is that when you're torquing the head bolts, back to what I said earlier about friction, you have to worry when torquing it, you have to worry about the friction on the head of the bolt, the washer, all of the length of the bolt, the threads, because as you exert a rotational force screwing that bolt down to you're introducing a twisting force while trying to clamp force down straight from the cylinder head to the block. So with the head stud, you eliminate a lot of that because you're not twisting the actual shaft, the stud. You don't have to worry about that length. All you're doing is tightening the nut and washer down against the mating area where it rests in the cylinder head. And with that special moly lube, I think it's a moly lube, you are basically going to know exactly precisely the torque output that you're putting the clamp load on that cylinder head. So much more accurate than bolts. It's got more holding power than bolts. It's an all-around upgrade. Like I said, normally something you'd only put in a turbocharged application. I have seen people put them in single overhead cam, naturally aspirated engines after a head gasket failure. Again, your money, you can spend it any way you want. If you want to stud in a 135 horsepower engine, go right ahead. But typically, it's only beneficial to turbocharged applications. So I know we've been a little bit all over the place with this video. I tried to keep it on track, but again, I get kind of scatterbrained and one thing leads to another. So we might have some more videos talking specifically about torquing and how torque is measured and fastening loads, things of that nature. I know we touched on a little bit here, but that was just to get an understanding of the head bolt situation. Pretty much covered what I need to cover. Long story short, like I said at the beginning, you're absolutely fine to reuse your head bolts. They're not going to stretch and deform. They're not designed to be a stretch bolt. You don't have to throw them away. So, with that said, thank you so much for watching. Hope you enjoyed. Hope you learned a little something. And I will see you guys in the next video.